Have you ever gazed at the night sky and wondered about the journey of those twinkling stars? Welcome to a tour through the cosmos, where we'll journey into the life cycle of stars, those radiant jewels that illuminate our universe. The life cycle of stars is an endlessly fascinating journey, a cosmic dance that spans billions of years and shapes the universe as we know it. The birthplace of stars is found within the vast cold reaches of space, in areas we call stellar nurseries. These are immense clouds of gas and dust, where gravity plays the role of a cosmic sculptor, molding these clouds into denser regions. It's within these dense pockets that a star is born, kindled by the pressure and heat of gravitational forces. The ignition of a star marks its entry into the main sequence phase, the longest period in a star's life. During this main sequence phase, stars, like our very own sun, are hard at work. They're burning hydrogen at their core, fusing it into helium through a process known as nuclear fusion. This process radiates an immense amount of energy, which we perceive as light and heat. It's this energy that powers life on Earth, makes our planet habitable, and is responsible for the warm, sunny days we enjoy. However, a star's journey is far from over. As they age, their path starts to diverge, dictated by their mass. Whether they're low-mass stars like our sun or high-mass stars, each star has its unique destiny to fulfill in the cosmos. Thus, stars begin their journey, illuminating our universe with their brilliance. They start as mere clouds of gas and dust, coalesce under the force of gravity, ignite into the main sequence phase, and radiate energy as light and heat. But this is just the beginning. Stay with us as we delve deeper into the intriguing, awe-inspiring journey of stars, a journey that tells the story of our universe. As stars age, their destiny diverges based on their mass. What happens to the low-mass stars like our sun? Low-mass stars, those with less than about half the mass of our sun, lead a relatively peaceful existence. They burn their hydrogen fuel slowly and steadily, spending tens to hundreds of billions of years in the main sequence phase. Yet, as the saying goes, all good things must come to an end. When a low-mass star exhausts its hydrogen, it begins to contract under its own gravity. This contraction heats the star's core, causing the outer layers to expand and the star to grow in size. In this phase, our once modest star has now transformed into a red giant. But the life of a red giant is not a calm one. The intense heat at the core of the red giant triggers helium fusion, creating carbon and oxygen. This fusion process, however, is unstable, resulting in pulsations that cause the star to throw off its outer layers. This expulsion of gas and dust creates a stunning spectacle known as a planetary nebula. A planetary nebula, despite its name, has nothing to do with planets. It's a luminous shell of gas and dust, a celestial butterfly emerging from the cocoon of a dying star. What remains of the star after this dramatic event is its core, now exposed to the cosmos. This core, known as a white dwarf, is about the size of Earth, but with a mass close to that of the sun. It's incredibly dense and hot, but without a source of energy, it begins to cool and fade. Over billions of years, it will dim until it emits no light at all, becoming a black dwarf. This final stage is, however, purely theoretical, as the universe isn't old enough for any white dwarf to have cooled to this point. So, low-mass stars conclude their journey, leaving behind a white dwarf as their legacy. This white dwarf, a cosmic ember of a once vibrant star, stands as a testament to the life and death of low-mass stars in the universe. High-mass stars, however, lead a more dramatic life. Let's delve into their fascinating journey. These celestial titans, born from the same stellar nurseries as their lighter counterparts, are defined by their intense gravity and temperature, which enable them to fuse heavier elements at their core. Unlike low-mass stars, which primarily fuse hydrogen into helium, high-mass stars have the capacity to fuse elements up to iron. Through a chain of nuclear reactions, they convert hydrogen to helium, helium to carbon, carbon to oxygen, and so on, until iron forms at the core. Iron, however, marks a turning point in the life of a high-mass star. Unlike lighter elements, iron does not release energy when fused. Instead, it consumes energy, leading to an unstable core. As iron accumulates, the core becomes increasingly unstable, until it can no longer withstand its own weight. This triggers a catastrophic collapse, resulting in a supernova explosion. In a brief, blinding flash, a high-mass star can outshine an entire galaxy, its death throes echoing across light years. But the story doesn't end there. The supernova explosion can give birth to two exotic entities, neutron stars or black holes. Neutron stars, remnants of a supernova, are incredibly dense, spinning at dizzying speeds and emitting beams of radiation. If you were to hold a sugar cube-sized piece of a neutron star, it would weigh as much as a mountain. Then there are black holes, the most mysterious objects in the universe. Born when a massive star collapses under its own gravity, black holes possess such powerful gravitational pull that nothing, not even light, can escape their grasp. They are cosmic enigmas, realms where the laws of physics as we know them break down. High-mass stars thus meet a dramatic end, leaving behind exotic remnants that continue to mystify us. The life and death of these celestial giants serve as a stark reminder of the universe's constant state of flux, a cycle of birth, evolution, and death that's been ongoing for billions of years. The death of stars is not an end but a new beginning. Let's explore how dead stars contribute to the cosmic cycle. When stars meet their demise, they leave behind a rich legacy that shapes the universe. These celestial bodies, in their death throes, scatter remnants into the vast expanse of space. These remnants, a mixture of stellar dust and heavier elements, form an interstellar medium that's ripe for the creation of new celestial bodies. Imagine, if you will, the remnants of a star that has just undergone a supernova. The explosion propels stellar material into space at incredible speeds. This material, rich in elements like carbon, oxygen, and iron, is scattered far and wide. It's not just a cloud of dust and gas. It's a celestial seedbed, a cosmic nursery teeming with the raw materials needed for the birth of new stars and planets. These elements, forged in the heart of dying stars, are the building blocks of the universe. They're the same elements that make up our planet, the air we breathe, and even us. Yes, you heard that right. We are, quite literally, made of star stuff. The carbon in our cells, the oxygen we breathe, the iron in our blood, they were all cooked up in the fiery furnace of a star's core. Life as we know it would not exist without this cosmic recycling program. The death of stars fuels the birth of new celestial bodies, providing the universe with a constant supply of building blocks. It's a cycle of death and rebirth, decay and renewal. But it's not just about the creation of new stars and planets. The remnants of dead stars also play a crucial role in the birth of life itself. The heavy elements they scatter into space are essential for the formation of complex molecules, including the ones that make up living organisms. In this grand cosmic scheme, the death of a star is not an end. It's a new beginning, a fresh start. It's the first chapter of a new story, one that could lead to the birth of new stars, planets, and perhaps life itself. In this way, the death of stars fuels the birth of new celestial bodies, perpetuating the grand cosmic cycle. The life cycle of stars is a cosmic symphony of birth, evolution, and death. These celestial giants, whether they be low mass or high mass, embark on a mesmerizing journey through the cosmos that plays a pivotal role in the grand scheme of the universe. Our journey begins with stellar nurseries, colossal clouds of gas and dust sculpted by gravity into dense regions where stars are born. This birth marks the beginning of the main sequence phase, where stars, like our very own sun, fuse hydrogen into helium at their core, radiating immense energy as light and heat. The fate of stars, however, diverges as they age, dictated by their mass. Low-mass stars, such as our sun, expand into red giants as they exhaust their hydrogen fuel. They shed their outer layers in a breathtaking display known as a planetary nebula, leaving behind a cooling white dwarf that fades into cosmic obscurity over time. High-mass stars lead a more intense existence. They fuse heavier elements such as carbon, oxygen, and iron. An accumulation of iron at the core signals their impending doom. These stars end their lives in a cataclysmic explosion, a supernova, releasing a burst of energy so powerful it can outshine an entire galaxy. The aftermath of this supernova can birth a neutron star or even collapse into a black hole, depending on the star's mass. Neutron stars are dense remnants that rotate at high speeds, emitting beams of radiation, while black holes possess gravitational forces so strong that they capture everything, including light. This grand cycle doesn't end with the death of a star. The remnants of dead stars scatter elements and heavy metals into space, serving as the building blocks for new stars, planets, and potentially life itself. This cycle repeats, with stellar nurseries birthing a new generation of stars, contributing to the ever-changing cosmic tapestry. Thus, the life cycle of stars is an integral part of the grand cosmic ballet, shaping our universe and influencing the existence of life itself.